now we're going to finish up section 2.1. We're picking up on page 7 of the notes, and the questions are now just asking us to find the vertex only. So the first equation that I've got here, first function I have is f of x is equal to x squared minus 2x minus 9. Remember my vertex. To find the vertex, I always find negative b over 2a. So that's negative 2 over 2 times 1, which is negative 2 divided by 2. Negative 2 divided by 2 is negative 1. Negative 1 is 1. What is f at 1? F at 1 is 1 squared minus 2 times 1 minus 9. 1 squared is 1. 2 times 1 is 2. Right? Whenever x is 1, it always comes out boring. 1 minus 2 is negative 1. Negative 1 minus 9 more is negative 10. So that means this parabola has a vertex at 1, negative 10. All right. Again, this is all these questions are asking of us. So let's not try to do extra work here. All right. Next, g of x is equal to 4 minus 7x squared. Well, this one's out of order, right? It should be in descending order. It doesn't really matter as long as you can determine a, b, and c correctly. A is the leading coefficient. It's the coefficient of the highest power of x. So it's negative 7. B, there is no b here, right? There's no term that has just x in it. Well, nothing in math means 0. If it's not there, it's 0, and then c is 4. So let's find the x coordinate. That is negative 0 over 2 times negative 7, which is negative 0 over negative 14. 0 divided by negative 14 is 0. Negative 0 is 0. Right? It's fine if 0 is in the numerator. It's when the 0 makes its way into the denominator that we start to have trouble. So I need the y coordinate. I jumped ahead of myself here. Oops. All right, I found the x coordinate. I need the y coordinate now. So what do I get when I plug in 0 for x? Well, if we do the rewrite like I have, that's negative 7x squared plus 4. Zero squared is 0. 0 times negative 7 is 0. 0 plus 4 is 4. So there's my vertex. My bad, I just got excited. Vertex of 0, 4. All right. Next, h of x is 1/3 x squared plus x plus 1. Yeah, b, find the vertex. B and a. Of course, I have a fraction here, and nobody likes that. So find negative b over 2a. B is 1. A is 1/3. So this is negative 1 over 2 times 1/3 is 2/3. And then the copy change flip rule says 1 divided by 2/3 is the same thing as 1 times the reciprocal, which is negative 3 over 2. I left the negative out front, I just changed 1 divided by 2/3 into 1 times 3/2, and then the negative came along for the ride. So what is h at negative 3/2? That is 1/3 times negative 3/2 squared plus negative 3/2 plus 1. All right, so let's do some math. I got to follow order of operations. Order of operations says I got to deal with the exponents first. Negative 3/2 squared is negative 3 times negative, or negative 3/2 times negative 3/2 is positive 9/4. Plus negative 3/2 is the same thing as minus 3/2. I'm going to use some reduction here to my advantage. The 3 and the 9 have a common 3. So that means I can divide that down or reduce. So now I have 3/4 minus 3/2 plus 1. And I'm going to work from left to right. 3/4 minus 3/2 is the same thing as 3/4 minus 6/4, right? In order to combine these fractions, I need a common denominator. The least common denominator between 2 and 4 is 4. How did I get that? I multiplied the top and the bottom by 2. So that's how I go from 3/2 to 6/4. 3/4 minus 6/4 is negative 3/4 plus 1. And I need a common denominator again. And that denominator is 4. So I need to multiply that 1 by 4/4. And I'll find myself with negative 3/4 plus 4/4, which is 1/4. So I've got a vertex of negative 3/2, 1/4. Okay. Calculator technology, all of that stuff is meant to be used here. You should be able to do this by hand, but if you're under a time constraint, obviously you'd want to use a calculator, computer, or whatever. All right. So let's jump on to the application problem from 2.1. And I find myself shooting a projectile off of a cliff 200 feet above water at an incline of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. The height h of the projectile above the water is modeled by h of x is equal to negative 32x squared divided by 50 squared plus x plus 200, where x is the horizontal distance of the projectile from the face of the cliff. Okay, so let's try to just get an idea of what we're talking about here. Cliff, ocean, whatever, right? And from the water to the top of the cliff is 200 feet. Okay, so I'm shooting from here at a 45-degree angle, so I'm expecting things to travel at a 45-degree angle, and then as time passes, gravity will pull down and the projectile will max out and then fall into the water. So I got a 200-foot difference between where I'm shooting from and the landing point. So the question is, at what horizontal distance from the face of the cliff is the height of the projectile a maximum? Now, first off, this one doesn't look, the formulas here don't look exactly like the ones you're used to. And the reason for that is that x, in this one, x is the distance from the face of the cliff. So it's the how far do I move to the right? Okay, so if this formula looks weird to you, yes, that square is supposed to be down there, but work with it. So what horizontal height from the face of the cliff is the height of the projectile a maximum? Okay, well, this equation, even though it looks weird, this is still a quadratic equation, right? This is still a parabola, right? X squared, x, and 200. So where does it max out? At the vertex, right? I'm looking at an A that's negative. So this is going to be a parabola. It's facing down. So I need to find the vertex. Negative B over 2A. All right. That is negative 1 over 2 times A. A is negative 32 over 50 squared. I assure you that I put that in the calculator just like everyone else did. I do this all in one step. Negative 1 divided by 2, open parentheses, negative 32 divided by 50 squared. And I find my answer to be 39.06 feet. All right. So it looks like my projectile is, if I'm launching at 45-degree angle, it looks like my projectile doesn't get too far away from the cliff before it maxes out, and then begins to fall. Okay, so there's the distance from the cliff face where I max out. What is the maximum height? Well, that's the that's going to be the y coordinate of the vertex. How do I find that? Plug in the x coordinate from the vertex. And again, calculator, because of that 50 squared in the denominator, I would not even begin to ask you to do that by hand. All right. So that maximum height is 219.53 feet. So what does that mean? That means I've launched. So as of right now, I launched my projectile, right? And it peaked. There's the max. This was 219.53 feet, and that's elevation off of the water. And then how far out am I from the cliff? I'm at 39.06 feet. Right? All right. And then at what horizontal distance from the face of the cliff will the projectile strike water? All right. So in this one, we're striking water. In previous examples, we have talked about hitting the ground. Whenever that happens, I need to be able to translate hit the water into my height above the water. Well, where does that happen? Where do I strike water? Well, right there. And then what is the height of that? Okay. Well, this is the height 0. So that means I take my original and I set it equal to 0 and I solve. So that is negative 32x squared divided by 50 squared plus x plus 200 equals 0. And you solve it. You're going to end up with large numbers if you do this by hand, because that 50 squared is going to come into play. But we can still use Desmos to our advantage. So let's plug in h of x, negative 32x squared divided by 50 squared plus x plus 200. All right. So there's our parabola. There's our maximum, which is where we said it was. Yeah. After 39 feet, I'm at 39 feet from the cliff face. I've reached my maximum of 219. And then the next question is, when do I hit the water? You can solve that equation, or you can use the graph here to help. And you'll find that it happens 170 feet from the cliff face. The last question is, when is the height of the projectile 100 feet above the water? I'm just going to take 100 and plug it in for y, which can't land directly on here. We can solve that by hand. Or, well, I mean, it's still going to be a bit of a mess. But when I did this out, it came out to 135 feet from the cliff face. Okay. Let's take a second look at this problem. Let's just see what we can do with it. Because if that goes into the quadratic equation, what happens? If that goes into the quadratic equation, a is 32 over 50, negative 32 over 50 squared, which is going to be squared in the denominator, which is going to be a big old mess. So what I would do is, yeah, just do exactly like we did here, using technology or a graph, and find that x is 170.02 feet. And now the interesting one, when am I 100 feet off the water? How far am I? So let's go back to Desmos and let me show you a nice trick. So I remember how I couldn't get this to land on exactly 100. What I'm going to do is create a horizontal line at y equals 100, and then find where do they intersect. And that's where they intersect. They intersect at 135,698. So let me put both of those points on here, and then let's take a little snapshot. That would be super helpful to insert that in. So we'll take a little screen clip here from Desmos, and then that'll let us know where we got these answers from. Okay. So again, these could come, they could be done by hand, but that's obviously not something, or it's just, that is just really not something that I think is worth your time. Okay. So, there. Okay. And what did we say? When am I 100 feet above the water? At 135, 698 goes to 670. 13570 feet. All right. Okay, so that's one application problem out of the way for 2-1. Let's go after another one. Suppose a family wants to fence in an area of their yard for a vegetable garden to keep out deer. One side is already fenced from the neighbor's property. Okay, so Family has enough money to buy 160 feet of fencing. What dimensions would produce the maximum area for the garden? And then B, what is the maximum area? Let's get a visual concept here. I'm going to fence in an area of the yard. So let's put it down like this. Now this, I'm creating a rectangle here. That does not, don't let that fool you, or don't think that that means that this has to be a rectangle, or when I get dimensions at the end that they may not make perfect sense. So what I've got here is, this is the fence from the neighbors, and then here are the this is the sides, and so I've got a fence over here. I need to buy 106. I can buy 160 feet of fencing, and I'm going to fence in these three sides. Right. So for rectangles and squares both, let these be the length, and this can be the width. All right. So what do I know about rectangles or squares? I know their perimeter, and I know their area just from old school, from way back. But remember, I'm not actually being forced to pay. I don't have to put part of my fence here because the fence from the neighbors is already here. So I'm just going to use that fence. And then all I've got to do is put together 2 lengths and 1 width. Okay, so if I buy 160 feet of fence, what dimensions are going to produce the maximum area? Well, I know that if I have 1 length plus the other length plus the width is going to be equal to 160. All right, so that's one equation. What I want to do is I want to maximize the area that this takes up. What's the area? Area is the length times the width. All right, so we've seen this in just really slow, or really just kind of just a little different situation. But I have 2 equations, right? I have 2 lengths plus the width is equal to 160. And I know that the area is equal to the length times the width. I want to maximize the area, okay? So I need to, if I got 2 equations, I need to take my first equation over there that's just got L and W in it, and I'm going to solve it for one of the variables. It doesn't matter which. One's easier to do than the others. And once I do that, I'm going to plug it in to equation 2 and see if I have something that can be maximized. So solve equation 1 for, I'm going to let it be W because it's super easy to do. Or substitute. W in equation 2. So let's do exactly what I just said. All right, so equation 1 is 2L plus W equals 160. I want W by itself, so I'm going to subtract 2L from both sides. So W is equal to 160 minus 2L. Now, I want to maximize area, right? So I'm trying to max this. Well, what is the area if I substitute in 160 minus 2L in for W times 160 minus 2L. Distribute. And 160 times L is 160L. 2L times L is 2L squared. Look at that. It doesn't look, it may not be obvious to you, but this is a quadratic equation, right? Highest power of the variable is 2. So what does that mean? If I have a quadratic equation, that means I have a parabola, right? Now, what is A? A for this quadratic equation is -2. B is 160. And C is 0 because it's just gone. All right? So my parabola opens down because A is -2. Since it opens down, that means I have a max at the vertex. So what do I need to do? I need to find the vertex. So find the vertex of 160L minus 2L squared. Well, to find the x-coordinate, that is -160 over 2 times -2. That is -160 over -40, which is negative 4. 4? 4, no. I added a 0 there for no reason. Sorry. -160 divided by -4. There we go. So that's -160 divided by 4 is -40. -40 is 40. All right. So there's the x-coordinate of the vertex. Okay. So that's L. Okay. So if that is L, can I find the other dimensions? Yeah. All right. So if this is L, because that's what question 1 asks us to do, if L is 40, then W is equal to 160 minus 2 times 40. 160 minus 80, which equals 80. So what are the dimensions to maximize my area? Well, I need a length of 40 feet and a width of 80 feet. And then the question is, what is the maximum area? Well, all it is just the plug in 40 to the original. The area, 160 times 40 minus 2 times 40 squared is equal to what? Put that in a calculator, and you're going to find the answer to be 3,200. So the maximum area is 3,200 square feet. All right. This is how these application problems are going to work most of the time. If you're given multiple equations, you're going to be able to relate one to the other, substitute in, and then just keep remembering what section we're in, what you're doing. If they want a maximum, then you can give them, you find that maximum by making sure you have a parabola and then finding the vertex, whether it's a max or a min. Okay. Now, skill questions 4 and 5. I've got what? I've got a quarterback throws a football with an initial velocity of 72 feet per second at an angle of 25 degrees. The height of the ball can be modeled by the equation h of t is equal to negative 16t squared plus 30.4t plus 5, where h of t is the height of the football and t is the time after release. This is what I meant on an earlier problem when I said the physics equation, this equation didn't look like the ones you'd seen before, right? When you started with this height equation, the coefficients are very different, right? This is what we're used to seeing, right? A is either negative 16 or negative 9.8. But here's the equation. Part A, determine when the ball will be at the maximum height. This is a parabola. It opens down, right? So this is a parabola that opens down, so the vertex is a maximum. Find it. All right. So the vertex, negative b over 2a. That's negative 30.4 divided by 2 times negative 16. 30.4 divided by 32, and that's negative, gives us what? Let's just do it here on the screen with you. 30.4 divide 32, 0.95. Negative times a negative, or negative divided by negative is a positive. So this is 0.95. Okay, so that's how long after it's released it reaches the maximum height. Part B, so 0.95 seconds. Units are critical here. Yuck. Looks like I'm making up new letters. 0.95 seconds. Maximum height. Right? Remember, that's still after the vertex. What is the maximum height? It's whatever I get when I plug in 0.95 to the equation. Negative 16 times 0.95 squared plus 30.4 times 0.95 plus 5. Okay? And what do I get? Negative 16.95 squared. I'm doing this all in one step on a calculator to avoid rounding issues. And I get 19.44. And what does that mean? That means the max height of the ball is 19.44 feet. And then determine the amount of time required for the ball to reach the receiver's hands if the receiver catches the ball at a point 3 feet off the ground. Remember a couple problems ago when I showed you how to graph this, graph your equation, and then graph a horizontal line? You could do that here, graph your quadratic or graph h of t, and then just graph the line y equals 3, find the intersection. Or you can do it mathematically. You can do it algebraically, excuse me. When is the height 3 feet, right? The question seems a bit longer than that, but it's not really. There's a receiver that's going to catch the ball. He's going to catch the ball when it's 3 feet off the ground. How much time is going to pass for that to happen? You're just taking the original and you're solving it. You set it equal to 3 and then solve. Okay. And here, let me show you what that looks like on Desmos. My function here is negative 16 t squared negative 16t squared plus 30.4t plus 5. And then when is this 3? And if we zoom in, it happens twice. Okay, it intersects twice, but this one doesn't do any good, doesn't mean anything to us because t is negative and t is time, right? So I don't want this one. This is an extraneous solution because I'm only interested in values where t is positive. And for this one, t is positive. The function equals 3 when t is 1.964. Let's plug that in so we can keep an idea of what we did here. All right, now we're on the penultimate page, next to last page, and we have regression, but it's not linear regression like you're used to. It's actually quadratic regression. So I have a table of values. It's representing a population of bacteria in the thousands versus the number of hours since the culture was started. So part A, use the regression to find a quadratic function to model the data, round the coefficients to 3 decimal places. All right, so the way I've done it is, again, using Desmos. You can use your calculator to do this as well, or any other technology you want. Here are all the data points from the problem. I was able to add that by just going to plus there and then table, and then just put everything in, 5, 37.7, 10, 60.9, so on and so forth. And what that did is it plots all the points. Then to get a quadratic regression, you type in, so notice the name of the lists. Y sub 1 is the set of all the y values in the table. X sub 1 is the set of all the x values. So what I need to do is tell the equation, I want you to approximate or give me your best regression model to represent this data, and I want it to be a quadratic regression. How do I get a quadratic? I get that form, ax squared plus bx plus c, but instead of x's, I use x sub 1's. Instead of y, I use y sub 1, and then I use a little tilde right here. And when I do that, I find my equation to be as such. Now, let's grab a screen clipping real quick and carry it over. So from Desmos, here's the output. And part A says to round the coefficients to 3 decimal places. All right, so y is equal to, remember this is ax squared plus bx plus c. I'm just creating a quadratic. What are A, B, and C? They're in the problem. They're in the answers right here, right? Here are the parameters A, B, and C. So that means I'm rounding to 3 decimal places, negative 0.173x squared plus 8.312x minus 1.386. So there's the quadratic. That is my best fit for the data given. Part B, use the model to determine the time at which the population is the greatest, round to the nearest hour. Oh, when is it the greatest? So part B, when is the population the greatest? Well, this is a parabola that opens down. It's got to be the vertex, right? So let's find it. Negative b over 2a is negative 8.312 divided by 2 times negative 0.173. That all goes into a calculator, and we find that 8.312 divide 2 times negative 0.173. So I find t is equal to this. So this happens at, round to the nearest hour, 24.02, which rounds to 24 hours. And then part C, what is the maximum population? Round to the nearest 100. Okay, so 24 hours in is when I'm going to see the maximum population. What is that going to be? Let's plug it all in and find out. So y is equal to, and all I'm doing is taking the quadratic up at the top right. I am plugging in 24 because the problem told me in part B to round to the nearest hour. So I'm going to take that rounded value and plug it in for x instead of trying to keep a whole bunch of unnecessary digits. So do this one again all in one step. 173 times 24 squared plus 8.312 times 24 minus 1.386. This is 98.454, round to the nearest 100. All right, so we got a couple things. We got to do a couple things here. This is so 98.454. All right. Now, remember though, y is thousands of bacteria, right? So this is 98.454 thousand bacteria. Right? So if I want to get rid of that 1,000, what would I do? Just every one of these 98 is 1,000, so just multiply by 1,000. So that's 98,454 bacteria, and then we were told to round to the nearest 100. Nearest 100. The hundreds are right there. So that 4 is the hundreds place. Look to the right. That means go up. So we're rounding to 98,500 bacteria. All right. And then lastly, we just have some true-false questions to finish up 2.1 with. And those are as follows. So true or false, the graph of a function can have two y-intercepts. All right, so I want you to think, is there a problem if I have two y-intercepts? So if I cross there and there, do I have a problem? Yep, I do have a problem because I failed the vertical line test, which means it's not a function. So false. Okay. The graph of a function f can have two x-intercepts. So let's say I'm here and here. Is that okay? Yeah, we've seen a couple of those, right? Parabolas do that. I can cross the x as many times as I want to. It's crossing y twice that causes a problem. So yeah, I can have two. If a is less than 0, then the vertex of the parabola is the maximum point on the graph. If a is less than 0. A is less than 0, the parabola opens down. So if it opens down, then the vertex is what, a max or a min? It is a max. All right, so that one is true. And then number 4, the axis of symmetry of the graph of f is the line defined by y equals c. All right. That is one to think about. Where does c come from? C is the constant from my quadratic equation. Let's see if this was true. Okay, let's go back to an earlier problem. All right, so if that last statement is true, then if f of x is negative 3x squared plus 6x plus 4, then that means the axis of symmetry would be y equals 4. Is the axis of symmetry y equals 4? No. It's x equals 1. Right? So that is false. Right? Axis of symmetry doesn't even have y in it. It actually has x in it because it's a vertical line every time. All right, that's section 2.1 done.